coordinate geometry. So our last section is fun section, and the last section we're going to do is it's how we use coordinate geometry to solve real life problems, but more in case in the world of kind of science and technology and STEM and business and that. So a little bit of a kind of a background on this first of all. So from the junior cert, you will know how to draw an axis, but more specifically, you'll also know how to draw an L-shaped axis where you have two variables. Okay, and usually one variable is the dependent and the other is the independent variable, that type of thing. Okay, that's the kind of idea you're kind of looking at here. So the idea of this is to use coordinate geometry to kind of put this all into a kind of a graphical graph, in other words, to be able to interpret it. So in science, okay, and you'll see this, some of you, if you're doing physics, you'll see it, someone doing business, you'll do it, but you get straight line graphs, for example. So I'll do, okay, proportional. One thing is proportional to another. So in other words, as this value increases and this value increases, the graph increases. And then you'll have what's called independent, or sorry, you'll have inversely proportional, where as one graph increases, the other graph decreases. And then you'll have directly proportional, where it goes through the origin, like this purple one. Okay? But what's important about all of them is no matter what variable you have, it's variable 1 or variable 2, and this is the important bit, how you plot the graph is usually based upon coordinates, in other words, inputs. So for example, let's say we're looking at, we'll use this one because it's Ohm's law. Let's use Ohm's law. Okay, from the junior cert, V over I is equal to R. Okay, V over I is equal to R. Okay, that type of thing. So resistance. So if I have voltage increasing this way and I have current increasing that way, the voltage will be the slope, or sorry, the resistance will be the slope. Okay, so how would you get it? Well, you'd plot a value here, and then you plot another value here, and that'll be your coordinate, your xy coordinate, but it'll be in terms of not x's and y's, but in terms of actual real life variables that you're being put in. And you might get another coordinate here, another coordinate there, another coordinate there, another coordinate there. And then you're asked to extrapolate or draw a line of best fit, a line of, I'm going to put this in bracket, best fit, that is close to every point. Now, of course, you can't be close to every point unless they're all lined up like ducks in a row. So what do you do? Well, we're going to do this in a different chapter when we're doing statistics, but a line of best fit, the best to look at a line of best fit is you try and pick a point that, represents the whole set of data as a whole. It could be the average point or something like that. And then all the other points should be equally above or below that. So in this case, let's say I picked this point to pivot my line on, okay, that point there, then I should have the same number of dots above and below. So I have 3 below and 3 above, let's say. So that would be a best line of fit. Whereas if I did another little graph here for you, I'll just show you down here. And let's say I had, these are all my purple points pointed. Then a line of best fit that would be very bad would be this one. That would be a very bad line of best fit. Why? Because you don't have an equal number of dots above and below. So you're not really trying to get close to all the dots at once. Okay. Obviously, the closer the dots are together, the more accurate the line of fit. But of course, what do we know about if you draw a line and you have coordinates for that line, you can get a slope for that line. It means you can get an equation for that line. And if you can get an equation for a line, you can then create a function that allows you to input an x variable or an output a y, or vice versa. So that's what we're going to have a look at today. How do we use coordinate geometry to allow us to build these things? So it's not as scary or as hard as you might think. Not. So we're going to give this one a go. So a carpet cleaner visits a house. His price, I can put it called C, is given by this formula. C is equal to, in euros, 20 plus 4 times M, where M is the scope. What we're going to draw is on a graph. Now that's my fault, not yours. And then we're going to have an investigation on some of the questions. Okay, so we're going to use 0 to, let's pick 80 as our domain. Okay, we're going to generate a range from that, and then we'll see where we go on this one. So let's draw an axis. Now, again, be generous drawing these axes. If you're not generous drawing the axes, what'll end up happening is you'll get a tiny little graph drawn and you won't be able to read off from your graph what the right answers are. So we have to draw a straight line. Now, you can put whatever one of them on the x-axis. I'm going to go with the, it'll make more sense when you put the meters, okay? Because the meters is what's determining the cost, okay? The money, okay? So it makes more sense to put that one on the x-axis, the one that's going to determine the other one. So we need to put some numbers in. So let's try and do a little table here. So if let's start with 0. C is going to be equal to 20 plus 4 times 0. So that one's going to be equal to 20 euro. So what does that mean? Well, that means that even if that means that just him to come out to have a look at your is going to cost you 20 quid, no matter what. So that's his call out fee, for want of a better word. So if we do C is equal to 1, or sorry, M is equal to 1, what are we going to get? Okay, we're going to get, we'll put a 1 in there, 20. I won't go up in ones, will we? I'm just trying to think now. If we go up in ones, we're going to be at this forever. Let's go up in tens and then we can just half it. Okay. So we go up in tens. Okay. Now you don't have to do this because we know this. There's no. This is a linear graph, so we could just pick the biggest number. You know. So if M is 10, the cost is 60. If M is 80, we go right to the top. If M is 80, rates are 32 and 20 is 34. The cost is 3,400. So you can see it's going to go up linearly. Now you could do all of them, but you won't need to because it's a line. So let's just put in a few of them. Okay. So I'm going to put in, let's say, 10 up to 80. That's what I want to do. There's 10, 20, 30, 40, 50, 60, 70, and there's 80. Now the cost I know has to go up to a max of 340. So go up in, I don't know, 50s. That's 6 of them. Okay. So there's 50, 100, 150, 200, 250, 300, and there's 350. Okay. So again, like anything else, you need to label these axes. Okay. Square meters. And that's whatever, 10 to, what do we say that one was, 80, and this is cost, and that's 50 up to 350. Okay, you can put in all the other axes if you want. I'm just being a bit lazy on this, and we're not starting at 0, we're starting at 20. So 20 is about there, but again, if you have graph paper, you're going to be doing this better. And what's our last one? It's 340. So 340 is about there. Okay. Okay, so let's join these. Now, so anything along that line can be fed back from both sides of this graph. So let's answer some questions. I suppose that's the best thing to do now. So let us see, what's the cost of 75 square meters. Number 2, how many square meters for €200? Number 3, let's say, let's see, find another one. Let's figure out 105 square meters. Okay, so now there are 2 ways of doing this, of course. Okay, Mr. Cheat would just sub in the value and get the answer. However, if you're asked to show it on the graph, then obviously what I would do would be sub it in, get the answer, and then show it. But let's do it from the graph, because you know what? I've drawn a nice half decent graph. Let's try and work it out. You know, nobody's gonna give out to us. Let's give it a go. Right? So let's see what the first one is. Cost of 75 square meters. Okay, so 75 square meters. And M is equal to 75. So if I were to replace it in there, but let's have a look at it. 5 square meters. There's 10. So 75 is straight up and straight across. So where are we looking at? Well, that's 50, 100, 150, 200. 3, it's going to be less than 325. That's what I'm estimating. Of course, if you have a graph paper, you will get the exact answer. So let's see, are we right? Okay, so for part 1, if we're saying C is going to be equal to, in euros, 20 quid plus 4 times 75. Okay, so, well, it's actually 320 quid, isn't it? C is equal, we were very close. And that's with me with no graph paper, but there you go. Okay, so let's have a look at the second one then. How many square meters for 200 quid? Okay, so how many square meters for 200 quid? Ooh, part 2. So 200 quid, let's go to 200 quid. There's 50, 100, 150, 200. Read right across. So it's down. Oh, I think we're going to be very close to halfway between 10, 20, 30, 40, and 50. We're going to go with 40, 50, 45. Let's see if we're right. If we're right, then €200 is equal to 20 plus 4m. So let's rearrange this. That's 180 divided by 4. 45. Okay, we were right. Okay, so M is 45 square meters you could get done. And the third part, right, 105 square meters. Ooh, see, it only goes to 80. So now we're stuck, aren't we? The only way we can do it really is if we extrapolate it up, or we just went, well, listen, we know that the cost is equal to 20 plus 4m. Cost is equal to 20 plus 4 times 105. So that is 105 times 4 plus 20, 440. Cost is €440. Okay, so that's if you want to go the full way. So there's a nice little example of one done. Okay, so again, with a lot of these, just take your time. Okay, there is a lot of ones, but they are rewarding in that you can get what you want. And the real trick of these, I suppose, is about the formula, because once you have a formula, you can work out. Okay, if you don't have a formula, you're kind of going to be stuck. So so what we'll do next is we'll see, can we work out a formula given a set of values. So let's draw a quick graph. Let's work backwards, as the man says. And let's say this is height, and this is, let me think, height and distance jumped in long jump. Okay, So listen, I'm pulling these out of my head. So, you know, I'm assuming there's some type of correlation between the two, but it doesn't matter. Just for the sake of our example, it doesn't really matter. So let's say there's some type of relationship between height as it gets bigger and the long jump. Okay, so that's 10 meters, let's say, and there's 5 meters, and there's 0, and then there's 1 meter, and there's 2 meters height. Okay, so and let's say the relationship is, let's say there's a linear relationship, it's not directly proportional, but let's say it's close. Let's say it's something like that. Okay, and all you know for sure is 2 points on it. Okay, you don't know anything about the other data on it, but you know 2 points for sure, and you know that at this point here is 1.8, comma 7. And let's say this one here is, oh God, is there any really, no, we can't use that point, can we? Because that's a bit of a silly point. Let's do one up here. Because I'm just going to think how many people are like, you know, that's like, this one's 1.2. And let's say 6, comma 6. Okay. No, we make that 8, will we? Yeah, 8 meters. Okay, so a fellow who's 1.8 can jump 8 meters. A fellow who's only 1.2 can jump 6 meters. Now, I know this is totally outside the realms of anything could happen in the real world, but for the process of how would you create a formula that would allow this line to represent all possible people, it's good enough. So how do we do it? Well, first of all, we need to work out the slope. So put down your points like before. So you have 1.8 and 8. And you have 1.2 and 6. And you have x1, y1, x2, y2. And you have y2 minus y1 over x2 minus x1. Get out your calculator. So that's minus 2 divided by 1.2 minus 1.8. Okay. That is 3 1/3, which is 10 over 3. Okay. So, you know, we're not going to 10 over 3. It's not the worst I've ever seen. So there's a slope. Now we need a point. We'll just pick whichever one you want. It doesn't really matter. We'll pick this one maybe. Okay. So now we have 1.2 and 6, x1, y1, and m equals 10 over 3. Formula that will represent this scenario. So y minus y1 is equal to m on m x minus x1. That's actually going to work out nice. Bottom left height, 3y minus 18 is equal to 10x minus 12. Okay, rearrange it. So what I would say to you here now is this isn't, at this point here now, we have to rearrange it in the form of y equals to mx plus c. Why do I say that? Because the whole point of these type of formulas is these are how you would present it to people. So I'll show you what I mean. This is how you would usually do it. You go 10x minus 3y plus 6 equal to 0. Okay, that's perfectly acceptable for leaving cert, no bother. However, what they'll be wanting is, if we're doing these type of questions where you're trying to put it into the real world, is you're going to have to go 3y is equal to 10x 10x plus 6. Y is equal to 10x plus 6 over 3. Okay, you see, you're with me so far? So you're rearranging to get y on its own. And then what you would do, y is equal to 10 over 3x plus 2. And then finally, they'd expect you, if they've given you code for height and distance, well then distance is equal to 10 over 3 times the height plus 2. And that's what they'd be expecting, this way of codifying it. So it's not just y and x, you're putting some code in with regards to the scenario that you're presented with. Okay, so listen, give a few of these a go. They are fun. If you should be grand on them. Thanks, boys. Bye.